we present DiffUHaul, a training tree method for repositioning objects in an image. Generative models have been used for a wide range of image editing tasks, aiming to ease the workflow of creative practitioners. One such task, which has recently gained attention, is the task of object repositioning. The goal is to take an image, mark one or more objects in it, and just move them to a newly designated spot. Of course, this requires not only copying the object, but also the ability to fill in its old position, and even the ability to identify and account for the object's impact on the environment, such as the shadows or reflections that it casts. Ideally, a generative model should be able to help us with this task, but existing solutions are not yet robust enough. They are great at copying, but they commonly also duplicate objects and struggle to reason over their environmental projections. Our goal is to improve this situation and give a user intuitive controls that can create images like these. So lately, a class of diffusion models has emerged that offers finer localized controls. These include models like LightGen or BlobGen, which allow a user to mark specific image regions with their own localized prompts that describe the content of that specific region. In such a case, we could hopefully even move the objects just by changing the locations of their blobs. But it turns out that simply moving the blob is not enough. Simply moving the blob has an impact on the entire image, including other designated objects. To fix this issue, we dive into these networks and identify a leak. One of the mechanisms through which blob-specific information is injected into the image is not properly disentangled and allows other image regions to directly attend to the conditioning blob. For example, in this image, we can see that the rabbit blob is attended not only by its own region, but also by the location supposed to contain the cat. And indeed, in the generated image, we can see that we have two rabbits instead of a rabbit and a cat. We then offer an inference time masking-based solution to this leakage problem. And this better localizes the effects of the different blobs and allows for more robust generation and also more robust dragging. In this example, our cat blob has returned to bring a proper cat. Of course, this is not enough on its own because nothing guarantees that the object itself will maintain its form in the new location. To handle this, we take inspiration from a recent line of work that shares self-attention features to improve the object's consistency across a range of editing tasks. We propose an adaptive time-dependent approach that uses our extra knowledge about object locations in order to more accurately copy the attention features and anchor them to the source image. Our full system can better leverage the greater spatial understanding of localized models without any training. It lets us handle more complex cases that are beyond the ability of current methods. For example, we can move this ball without also forgetting to move its shadow. Similarly, we can drag a bench, and in this case, I mean the entire bench. And we have many, many more examples, including both generated images and real ones. For more details and examples, please read our paper. Thank you.